Hi friends, welcome back. Mrs. Gradney here, and today in our lesson, we're going to be finding factor pairs for numbers to 100, and we'll also be learning about two new types of numbers. Let's get started. Let's start with something we already know. Look at these two arrays. What multiplication sentence matches this array? 1 times 8 equals 8. Great. And what multiplication sentence matches this array? 2 times 4 equals 8. So both of these arrays show a product of 8, and 1, 8, 2, and 4 are factors of 8. Here are two new arrays. Take a moment to analyze them. What product is represented by both arrays? 18 is the product. Pause the video here, draw both of these arrays, and write the multiplication sentence to match for each one. Hopefully you wrote 1 times 18 equals 18 and 2 times 9 equals 18. Now what are the factors in the multiplication sentences we wrote? Circle them. The factors are 1, 18, 2, and 9. Pause the video now and write these factors of 18 that we just found in order from least to greatest. So far, for the factors of 18, we have 1, 2, 9, and 18. Pause the video now and draw another array with a product of 18 that represents two different factors than we found so far, and write a multiplication sentence that matches. Then come back and we'll compare. Did you draw an array that represents 3 times 6 equals 18 or 6 times 3 equals 18? What new factors of 18 did we find? Now we can see that 3 and 6 are also factors of 18. So let's add them to our list of factors of 18. Now we still want our factors to be in order from least to greatest. So we'll need to move 9 and 18. So we have 1, 2, we'll add 3, 6, and add 9 and 18. So now for our factors of 18, we have 1, 2, 3, 6, 9, and 18. But how can we be sure that we found all of the factors of 18? What if there are more factors of 18? Pause the video to talk out your thinking. Maybe you're thinking that you could just think through all of your multiplication facts or use a multiplication chart to help you. Or maybe you're thinking you could try to draw more arrays. We already have an array drawn with 2 as a factor and another drawn with 3 as a factor. So we could try to draw an array with 4 as a factor and 5 as a factor all the way up to 18. But if the number were really large, like 92 instead of 18, then that would take us a really long time to try to draw all those arrays. So let's try this. Look at our list of factors of 18. We can draw an arrow from 1 to 18 because 1 and 18 is a factor pair. Because 1 times 18 equals 18. We can multiply them together to get 18. Think about what you know about pairs. When we talk about a pair of shoes, we're talking about 2 shoes, right? It's the same with factor pairs. When we talk about a factor pair, we're talking about 2 factors that when we multiply them together, we get a certain product. Pause the video now and draw more arrows to connect the other factor pairs of 18. So what are the factor pairs of 18 that we have? 1 and 18, 2 and 9, 3 and 6. So how can we use this to help us decide if we found all the factors of 18? Well, take a look at that middle factor pair, 3 and 6. We've checked all of the factors up to 3, 1, 2, and 3. And the only counting numbers between 3 and 6 are 4 and 5. So think, is 4 or 5 a factor of 18? No, neither 4 or 5 is a factor of 18. So that means we found all the factors of 18. Now it's time for you to try one. Pause the video and find all of the factors of 8 and list them in order from least to greatest. And explain out loud, how do you know you found all the factors of 8? Then come back and we'll discuss. Does your work look like mine? To explain how we knew we found all the factors of 8, maybe you were thinking we could connect the factor pairs 1 and 8, 2 and 4. If we look at that middle factor pair, 2 and 4, well, we found all the factors up to 2, and the only counting number between 2 and 4 is 3. Since 3 is not a factor of 8, we know we found all the factors of 8. Nice work. Let's try another one. Read the equation. 2 times 8 equals 16. What's the product? The product is 16. And what are the factors? The factors are 2 and 8. Pause the video now and think about what other multiplication sentences we could write with different factors that would give us the same product, and record the multiplication sentences you come up with. Did you think of 1 times 16 equals 16 and 4 times 4 equals 16? What are the factors in these multiplication sentences? The factors are 1, 16, 4, and 4. So let's list the factors of 16 in order from least to greatest. Pause the video to do that now. So our factors of 16 are 1, 2, 4, 8, and 16. Now, should we have written 4 twice? Because it is 4 times 4. No, we didn't have to write 4 twice. When a number is multiplied by itself to get a product, we still only record that number once when we're listing the factors. Now, are we sure we got all the factors of 16? Pause the video to explain your reasoning. Maybe you were thinking we could draw arrows to connect the factor pairs like this. We can see we have 1 and 16 as a factor pair, 2 and 8 is a factor pair, and 4 and 4 is a factor pair of 16. Between 2 and 4 is the counting number 3. 3 is not a factor of 16. Between 4 and 8, we have 5, 6, and 7, none of which are factors of 16. When we get to 8, we notice we already have its factor pair, 2. And since 8 is halfway to 16, we don't have to go any further or check any more numbers to see if they're factors of 16. We know we found them all. Great job. Let's try another one. Read the equation. 1 times 7 equals 7. What's the product? 7 is the product. And what are the factors? 1 and 7 are the factors. Pause the video and see if you can find another factor pair with a product of 7. So what did you find? Were you actually able to find another factor pair that gives us a product of 7? Let's think about the factors of 7. If we list the factors we have so far, 1 and 7, and we think about the numbers in between 1 and 7, 2, 3, 4, 5, and 6, none of those numbers are factors of 7. 1 and 7 are the only factors of 7. How is that different from the factors of 8, 16, and 18 that we found earlier in the lesson? 8, 16, and 18 all had more factors than 7 does. 7 only has one factor pair, 1 and 7, and the other numbers had more than that. Let's think about another number. Think about the number 5. What's a factor pair that would give us a product of 5? We know 1 times 5 equals 5, so we can list the factor pair 1 and 5. Are there any other factor pairs that would give us a product of 5? Think about the numbers between 1 and 5, 2, 3, and 4. None of those are factors of 5. So 1 and 5 are the only factors of 5. Numbers like 5 and 7 that have one factor pair or exactly 2 factors, 1 and itself, are called prime numbers. Everyone say prime numbers. Pause the video now and see if you can discover at least two other numbers that are prime numbers. Remember, a prime number is a number that has only one and itself as factors. Here are the prime numbers I came up with: 11, 13, and 17. Though these aren't the only prime numbers, there are more. Did you come up with others? Now, if these are prime numbers, can you name some numbers that are not prime? Maybe you said 6 is not a prime number, or 8, or 9, or 12. All of these numbers that we just listed have more than two factors. They have at least one other factor besides 1 and the number itself. These numbers are called composite numbers. Everyone say composite numbers. Let's take 6 as an example. Does 6 have more than two factors? Well, we know that we can multiply 1 times 6 to get 6. But we can also multiply 2 times 3 to get 6. So that means 2 and 3 are also factors of 6. So what does that mean for the number 6? It's a composite number. Let's try another one. But this time we're going to use a table to record the factor pairs. So pause the video, draw a table like mine, and then come back and we'll find the factor pairs for 35. Now, at any time, as we're finding the factor pairs for 35, if you need to, feel free to pause the video and use a strategy such as skip counting or drawing an array to help you. So what would be the first factor pair for 35? 1 and 35. Because 1 times 35 equals 35. Let's move to the next number, 2, and try 2. Is anything times 2 equal to 35? Nope, nothing times 2 equals 35. So 2 is not a factor of 35. Let's try 3. Is anything times 3 equal to 35? Nope, nothing times 3 equals 35. Let's go to 4. Is anything times 4 equal to 35? Nope, nothing times 4 equals 35. Let's try 5. Is anything times 5 equal to 35? Yes, 5 times 7 equals 35. So 5 and 7 is our next factor pair. Now, the only counting number between 5 and 7 is 6. So let's try 6. Is anything times 6 equal to 35? Nope, nothing times 6 equals 35. So 6 is not a factor of 35. Now, should we continue on and test to see if 8 is a factor of 35? Pause the video to explain what you're thinking. No, we don't have to test to see if 8 is a factor of 35. We've already tested all of the numbers up to 7, and we found that 5 times 7 is a factor pair for 35, which means that there won't be any more factors of 35 that are greater than 7. So, looking at the factor pairs for 35, is 35 a prime number or a composite number? And how do you know? Pause the video to explain your thinking. Hopefully you said 35 is a composite number. And we know this because it has more than one factor pair. It has more factors besides just 1 and itself. Pause the video now and use a table like we just did to list the factor pairs for 23 and 48 and tell whether each number is prime or composite and how you know. Then come back and we'll discuss. Welcome back. Does your work look like mine? How did you know 23 was a prime number? 23 is a prime number because its only factors are 1 and itself. What about 48? How did you know 48 was a composite number? 48 is a composite number because it has lots of factors, more than just 1 and itself. In fact, we found 10 factors for 48. Great job. Excellent work today, friends. I think we're ready for the problem set. On the screen are the must-do problems for the problem set. Work on these problems for 10 minutes, and if you finish early, feel free to try any of the other problems on the problem set. Today, we found factor pairs for numbers to 100, and we learned about prime and composite numbers. Be sure to check in with your teacher, and I'll see you next time for another Eureka Math lesson. Bye!